So I think we'd finished chapter 3. We were on the summary page on the PowerPoint. So spaghetti code, statements that do not follow rules of structured logic, enabled by the goto statement, which most languages no longer have. So the 3 basic structures: sequence, selection, and loop. Sequence is just one instruction after the other. A selection is an if statement. There's another kind of selection called a case and a switch, but we have the if statement, so that's what we're going to use. And then the loops. And you combine those structures with stacking them and nesting them, putting if statements inside of while statements inside of if statements. That's called nesting. And then by organizing things in modules, which I would have called a 4th structure, but they didn't. And then, so what is a priming input? That's when you read a piece of data in before your loop to get your loop going, and then you have another read inside the loop. So, structured programming structures promote clarity, professionalism, efficiency, modularity. Glad to know it. So really, if your goal is to try to write code that's easily readable, that's just kind of really important. If it's easily readable, it has a good chance of being something that you could understand and that somebody else could understand once they're looking at it with you, or after you. Flowcharts can be made by structured by untangling logic. I didn't even work us through the thing where we have a flowchart that's impossible to implement in a structured code language and then we fix it. We're just going to design our programs from the ground up to work in structures using if statements and loops and stuff like that. Logical steps can be rewritten to conform to the 3 structures: sequence, selection, and loop. Like I said, I didn't take us through changing code that's not structured into structured. Yeah. We're starting from the ground up with if statements and while statements. We don't need to worry about that. So making decisions. The selection structure, the if statement. Relational comparison operators, less than, greater than, that kind of stuff. We basically already know that stuff. And, or, and not. How to make a selection within a range. Also, you can make a selection that's outside of the range. Precedence when combining and an or, and the case structure, which I mentioned we do not have in this language. So all of this stuff, all these ifs and whiles, etc., ultimately rely on the fact that an expression can be boiled down to true or false. A is less than B. C is not equal to 0. That kind of stuff. That's known as a Boolean expression. A Boolean expression is one that ultimately evaluates a true or false. Boolean math is a math in which there's only 2 possible values and 2 possible numbers in the entire system, 0 or 1, or true and false. So every decision yields a true or false, a yes or a no, a 1 or a 0 result, which is used in the selection structures. For example, the dual alternative, we've already mentioned this, provides an action for each of 2 possible outcomes. Is A less than 0? Yes, print an error message. Else do the calculation. That kind of thing. The single alternative selection structure is when the action is provided for only one outcome. Is A less than 0? Yeah, print an error message. Otherwise, don't do anything, right? That's just an if rather than an if-else. This is an if-else. We see that in else branch. This one has nothing on the other side, so it's just an if. So the if then else. Now else is not a box on a flowchart. There's no box called else on it. And the reason I mention that is because we use the term so often, if then else, just like the word then. There's no then box on it. There's no symbol to put the word then in, and there's no symbol to put the word else in. If you really wanted to, you could edit where it says yes and put yes slash then and no slash else, but why bother? That takes time. But there is certainly an else keyword. So the if-then clause is the first one. It holds the actions that execute when the tested condition is true. If x is less than 0, print invalid input. So that's the so-called then clause. Some languages actually had the word then, which seems to have been abandoned. You know, if x is less than 0, you know, then colon do something, print something, else print something. Kind of makes sense, but no. We don't have a then keyword in any of the languages you're likely to be using. And then the else clause. The else clause executes when the tested condition is false. When this value is false, when that Boolean expression is false. Whenever you have an if-else, you could always rewrite it. If you wanted to put this stuff inside the then and this part inside the else, you just have to flip the logic of this. Now, there's no particular reason to say that I would want to do this, but say that I liked putting invalid input as the last thing in my code rather than the first. I could change these. I can move that up there. I can move this down there. But then I have to reverse this. So instead of x less than 0, I would need to make it x greater than or equal to 0.
Wait, why are you flipping it again?
The why is no particular reason. I'm just illustrating that you can flip the logic. Right. It's not that you had to do that. So when you're looking at your code, you might... It's a very good question, by the way, because the reason I would do this is, what if my code looked like this? It had a whole bunch of stuff here. Now I wish I was in a real programming editor so I could have that. And then I had one final else there down at the very bottom. I might want to reword it so that the short one was at the top, and then, you know, the rest of it was all at the bottom. Just you know, so that conceptually I can see we rule out one condition. Now usually you rule out the invalid input first, and so this illustration that I've come up with is kind of dumb because it already had the invalid input being at the first. So that is how I would program it usually. I would write it in such a way that the invalid input was the then, and then all the good stuff was in the else. But that gets kind of annoying to flowchart. Anyways, so if you want to reverse the if and the else clauses, you just have to reverse this expression. You have to reverse the truthiness of it. Notice that it's less than here. I didn't just say greater than. I had to make it greater than or equal to, because the opposite of less than is not greater than, as you would expect. It's greater than or equal to. Why? Because you also have to handle 0. What if x equals 0 here? Which is it going to print, invalid or valid? Well, if x is 0 less than 0? No, so it's going to print valid input. But if I had this like this, x is still 0. It's going to print invalid in that case, when it would have printed valid here. So I didn't perfectly flip the logic of it. So I had to do that. So just remember that the opposites, you have to handle the equals case as well. Opposites. So this is opposite of that. This is opposite of that. And then there's equal, which is opposite of not equal. Now Python has another keyword that you could use to flip the logic, which is the not keyword. You could say this, if not x less than 0. Now to me that makes it more difficult to read. But it does the same thing. It takes whatever that was, and if it was true it becomes false, and if it was false it becomes true. So if we were cruising in here with 0 as our input, it would print valid input. And then if we were cruising into here, we'd go, is x less than 0? 0 is less than 0. No, that's not true. That's false. But okay, not false is true, and it would print valid input. I'd really rather not do that. I'd really rather just make it say x greater than or equal to 0. So the relational comparison operators are just the ones that I listed. For numeric values, you can do all that. Now you can't compare strings to numbers. You can't say, is Fred less than 13? Yeah, if Fred was a variable, great, but you can't do this, if Fred is less than 13. You really can compare things like that. You can compare strings to each other, in which case it just figures them out on alphabetical order. You know, F's are greater than B's, and so that is a false. That is not a true expression. But typically you think about relational comparison operators as being for digits, for math. You know. So the two values compared can be variables or constants, but they have to be of the same data type. So that's when I said if, you know, Fred is less than 3. That's not going to work because they're not of the same data type. Can't compare things of two different data types. Now the computer will, behind the scenes, sometimes do a little bit of fixing in order to make sure that the things are the same data type. Like ultimately, deep down inside the guts of the computer, a floating point number is stored in a very different way than an integer number. But that doesn't matter to us in this language. The language goes, oh, you've got two numbers, I'll handle it for you. I know what to do there. So, where was I going with that? The things to be compared need to be of the same type. They can be variables, they can be constants. You could do if, you know, x is less than 3, if y is greater than x, you know. They can be even expressions, if x plus 3 is less than y plus 7, right? But ultimately, this is going to evaluate to a number, this is going to evaluate to a number, and so then they can be compared relationally. Trivial expressions. Is 20 equal to true? Yeah. Excuse me, is 20 equal to 20? It sure is. Now I'm going to put double equals there. Why? Because that's what the computer wants to see. You will get into error. You will make syntax errors if you mix those up. If you do this, you know, if you were changing some pseudocode to programming code, and then so you said, well, I'm going to write that as x equals 10. No, that's a syntax error. When you're assigning a value, you have to use a single equals. And then when you're comparing, use double equals for comparing. You'll get syntax errors if you try to do it the other way. A couple of languages will let you do this, but what happens is if you just wrote it like that, if x equals 10, it would take the value 10, erase the contents of x, and replace it with the number 10. You don't want to erase your data, you're trying to compare it. This language doesn't even let you make that mistake. So why is this called a trivial expression? Because these are two literals, these are two constants. They can never change. This expression will always be true. This expression will always be false. The ultimate trivial expression is just saying something like if that. And I'll actually take advantage of that sometimes. Sometimes I'll do while true. That's a trivial expression that always evaluates. Most of the time you want to avoid trivial comparisons. Why would you want to do if 20 equals 20? But the while true loop has a special place in my heart. Let's keep going. Relational comparison, the equivalency. We should be calling this the equivalency rather than equals, but I'm always going to call it equals, right? Evaluates as true when these are the same. Greater than. We know what greater than means. We did this in elementary school. The alligator mouth is going towards the bigger value. You know, x greater than y. Less than is 3 less than x. Greater than or equal to. I think we know how that works as well. Less than or equal to. And then not equal to, except no language I know uses that. So here is what our not equal to operator is.
I guess I'll make a point that the book up here when I was listing them is our not equal to operator, but the book mentions that as meaning not equal to, which is great and all for a math book, but no computer language I know ever uses that to mean not equal. What was I going on about here? Why was I comparing 3.0 to 3? Oh, just to say that they had to be of the same data types, or if they were of different data types, whatever, I'm going to delete that. That's confusing me. All right.
So if we were going to be, if we got homework, we were writing a program, if we had to put something that's not equal to something else, we would use the exclamation point?
Yeah, exactly, exactly. Anytime in pretty much any programming language you're going to find, if you want to say not equal to, you do it that way.
And then, but what about, but the double equal, whatever, yeah, that.
Don't use it anywhere. Right.
No language uses that at all?
I've never seen it. But it's in the book. The, it's in textbooks for math, algebra and stuff like that, and I guess they just borrowed it from there. I'm sure there's a reason why they did that, why they put it there. Okay. So we know what not equals means. He evaluates the true if the operands are not equivalent. There's that word, operands. Operands are the two pieces of data that a so-called binary operator works on. A binary operator is one that has to have two pieces of data in order to work. Like, you can't check to see if something is not equal to something else if you don't have two pieces of data. So that's the operator, and X and Y are the operands. So in this case, binary operator doesn't mean it's all zeros and ones. It just means that it requires two pieces of data. For example, if X greater than Y. So greater than is the operator. X and Y are the operands. So any decision could be made with only these three types, I suppose, but I sure do like having the greater than or equal to and the not and the less than and equal to options, so I'm not sure where they're going with that. The not equal operator involves thinking in double negatives. Best to restrict the usage of not equal to if without an else. That is, take an action only when a comparison is false. And what they are saying there is that if you're going to word something like this, if X not equal to Y, do thing A, else do thing B. Our brains handle it a lot better if we flip it and say if X is equal to Y, do thing B, else do thing A. Right? It's far easier to go, oh yeah, if X equals Y in our heads. Computers don't care. And then saying if X not equal to Y, do this, else do this. Because by the time your brain gets down here, you see what I'm saying? This is just easier to read, but they do the same thing. They do the same thing. So there's no law. The book is just suggesting that you shouldn't use not equal in an if unless it's only a single alternative if. Right? If X is not equal to Y, do single thing. Whatever, That's cool. But if you're going to throw an else clause in it, then you may as well have worded it equal. I'm kind of skipping past the flow chart under the assumption that we have talked about this stuff, but I guess I may as well hit it again. So if the customer code is equal to 1, if we were going to be writing this in actual programming code, we would use two equals there. If customer code equal. And there's no then word in programming, we would just put a colon there. And then discount is equal to 0.50, else colon, discount is equal to 0.25. So you have a yes branch and you have a no branch. If it really bugs you that there's no else keyword, excuse me, there's no else block here, just make it say no/else right there. Just double click on that word no and change it to no/else. Don't bother on my account. Common errors using the wrong operator. Well, yeah, I guess if you're checking if something's less than, but you needed to use the greater than, that's certainly an error. Missing the boundary limit required for a selection. Now that is a big deal. When you're checking to see if something's a problem, you need to figure out whether your comparison needs to be inclusive or exclusive. And when I'm doing these examples about freezing or boiling, I never remember if you would you say something boils at a certain temperature or above a certain temperature. And what I mean by that is at the boiling point of water at sea level, 1 atmosphere pressure in Fahrenheit is 212 degrees. And so if I was going to write this logic, if x greater than 212, print boiling. Is that strictly textbook correct? Or does it actually start boiling at 212?
Start boiling at 212.
So we ought to make it that.
Yeah.
So you just need to kind of be, and unless I'm specifically looking for, whether you're going to make that error or not, I wouldn't count you off for doing that in many cases. And I'll probably get it wrong up here. But
same thing for, checking less than. Is something freezing at 0 degrees or does it freeze below 0 degrees?
By that reason.
So should I make it less than or equal to print freezing? All right. Sounds good to me. So if you were going to print whether something was liquid or not, you could use the or keyword. If x is, the and keyword. If x is greater than or equal to 0, if x is greater than 0 and x is less than 212, print liquid, right? It hasn't frozen yet. Liquid, okay, like that. That's how you check within a range. So what the and keyword means, as I think we've already talked about, is that both sides have to evaluate to true before the whole thing evaluates to true. So if x is not greater than 0, or if x is not less than 212, then it would not print liquid. If you're going to check outside of a range, you don't use and, you use or. So to check in a range, use and. So now we're going to check to see if it's outside that range and print not liquid. We could just flip it with the not keyword, as I mentioned previously, but I'm going to rewrite the expression. If you use and to check to see if it's in a range, you use or to check to see if it's outside of the range. So if x is less than or equal to 0, or x is greater than or equal to 212, print not liquid. Why is that? Because if it's less than 0, it's freezing. If it's greater than 212, it's boiling. In either case, it's not liquid. That's ignoring the fact that there's a transition phase, right? For a certain amount of time, it's still liquid and. Okay, so anyways, you use or to see if something is outside of a range. And when I flipped the logic in order to get the opposite, remember that I used I changed greater than to less than or equal to. And when I changed less than to greater than or equal to. Just to make sure that I maintained my, inclusive or exclusive rules. That's not right, though. How come nobody yelled at me? What's the freezing point of water in Fahrenheit? It's not 0.
Yeah, 32.
Yeah. Alrighty.
I was thinking Celsius.
Right. I kind of switched gears. I was using half and half.
Gotcha.
So you understanding and compound conditions. You can add multiple questions before the outcome is determined. If your money is greater than 0 and, honey, and your hunger level is greater than 0, go out to eat. We can't go out to eat if we don't have any money. We can't, no reason to go out to eat if we're not hungry. So this is a compound expression. But maybe you have a friend who could take you out to eat. So you could modify your logic, make it even more complicated. If friend's money is greater than 0, or your money is greater than 0, then that handles that. And hunger is greater than 0. Go out to eat. Like that. So we're building compound logical expressions there using and or. And or means that only one of them has to be true for the whole thing to be true, and means that both sides has to be true. So you can go out to eat either if you have money or your friend has money. If you both have money, great, even better. But one of these conditions has to be true up here for it to evaluate the true. We're not going to go out to eat if we don't have any available money and if we're not hungry. Why did I put parentheses here? Because just like multiplication and division and addition and subtraction have an order of precedence, so do logical ands and ors. And has a higher precedence than or. So just like when we said 1 plus 2 times 3, and we were going to store that in x, what does x equal?
7.
Right, it's not 9, it's 7, because this had to be done first.
Yeah.
So if we were going to express this logically, if A or B and C, which is the way this is expressed, except these are actual expressions rather than variable names, then this gets clustered together, just like this gets clustered together. But we didn't want to cluster these two things together. If this question mark had been left out, then when the compiler was going, it'd say, oh, there's an and, I'd better do that first. So this is going to be the first thing that I check, is to see whether your money is greater than 0 and hunger is greater than 0. That's not correct. We wanted to see whether we had money or friend had money. So we use parentheses to force the order of evaluation, just like if we had wanted the 1 plus 2 to be done first, we could have. Right, we could have done that, and then the 1 plus 2 would have been done first. So in this one, multiplication happens first, and in this one, and happens first. Why did I put parentheses around there? Just a habit. Some languages require them after if words. Python doesn't, but it doesn't break them. So why is that the case? Because if we treat 0 as false and 1 as true, then when we do our little binary tables, we're doing here's x, here's the y, and here's the result. And if the expression that we're doing is x and y, well, false and false is equal to false. False and true, I don't have any money, but I'm hungry. Too bad. I still don't get to go out to eat. False. I have money, but I'm not hungry. Well, forget it. I'm not going to go out to eat. I have money, and I am hungry. Woohoo, our golden condition. Let's go out to eat. So that's the and truth table. And then there's the or truth table. X or Y. Same thing, we're pretending that zeros are falses and ones are trues. So what's my classic example for or is if and. If sick or tired, stay home. So here we go. If we're not sick, we're not tired, then we are not going to stay home. What if we are not sick, but we are tired? Yeah, sure, why not? Stay home. We don't need the money. All right. And then if we are sick, but we are not tired, stay home. If we are both sick and tired, stay home. So you see the difference. When you're using and, the only time and is true is when both inputs are true. The only time or is false is when both inputs are false. But this also looks like multiplication. 0 times 0 is 0. 0 times 1, still 0. 1 times 0, 0. The only time that you could multiply any of these numbers together and get anything else other than 0 is if they're both 1. 1 times 1 is 1. Now this looks like addition. 0 plus 0 is 0. 0 plus 1, 1. 1 plus 0 is 1. 1 plus 1 is, well, should be 2, right? But this is the universe in which there's only 2 states, 0 and non-zero. So 1 plus 1 is equal to 1. So in logic terms, and if you ever go and take a logic class, you may see this. And multiplication are synonyms, meaning they mean the same thing. Or and I should have put a slash there. And addition are synonyms. I don't know if that'll help you remember that ands get done before ors, but multiplication certainly happens before addition. So maybe that'll help. Otherwise, just remember it. So the AND decision requires that both tests evaluate to true. You can implement it using a nested decision or a cascading if statement, or you can use the AND keyword, which is how we would do it. But there's always more than one way. Like if we were going to do that if hungry and have money. If hungry, if we have money, go out and eat. Right, that's one way to do it. That's known as an if cascade, a cascading if. It's just a nested if, right? This if is nested in here. Kind of slipping back into pseudocode there with our little end if comments. Okay, so sure, that's how you could word it, but we would rather do it like this. If hungry and money, go out and eat. Same thing. So when you're nesting your decisions, either one can come first, but the performance time of your program can be improved by asking questions in the proper order. What do I mean by that? What if this decision takes 1 minute to do, and this one takes 1 second to do, 1 second to check? For some reason, we have to wait a whole minute to decide if we're hungry, but with 1 second, glance at our bank account, we know whether we have money. Is this the most efficient way to word it? Well, what if we had to do this check 10,000 times? Would we rather do it like that, or would we rather do it like, let me do a little bit of rewriting. Money, hungry, this takes 1 second, and this takes 1 minute. Okay, so if we had to do this 10,000 times, this would mean that every time we check this, we have to wait a minute to find out if we're hungry, regardless of whether we have any money or not. This block of code is going to always take at least a minute. But what if we write it like this? This is the faster one. Money can be checked in a second. If we can rule that out instantly, then we've got a big time improvement. What if they take the same amount of time, but one of them is true much less often than the other? Let me copy one of these and remove my comments. So now we're not talking about how long it takes to check them. We're talking about how often. Hungry, we're almost always hungry.
Yep.
This is usually true. Money, this is rare. Money, this is rare. Hunger, this is usually true. One of these is more efficient than the other. If this is usually true, but this is rare, then this is less efficient than doing it this way. Because if you could rule it out right away, well, I don't have any money, I'm not going to even check to see if I'm hungry, then it won't do the extra test. Because everything, in the programming, in the computer, does take a finite amount of time. Now, if you were trying to write really fast code, you wouldn't be writing in Python. Call of Duty and Fallout and everything are not written in Python because they're not the fastest. But this is not a Python specific book, and it's a very valid point that in a AND condition, you want to put the rare one first because you want it only going inside the loop and doing the extra work in the rare occasion that this is true. Whereas if we worded it this way, we'd always be doing both checks. We'd almost always do both checks because the first one is usually true. But here, we would usually only do one check rather than both checks because the rare one was listed first. Or works the opposite way. So we'll just put some comments here. Which is more efficient? The second is more efficient. Here. Because this would require us to wait a whole minute before we could even check the second state. This one lets us rule it out within a second, and we don't have to do that minute-long check. So the second is not more efficient. The first one is more efficient. No, that's correct. The second is more efficient. And here, if we assume that both checks take the same time, but that one condition is more likely than the other, which is more efficient. The one where we have to check them both, usually, or the one where we usually only have to check the first one.
The second one like that.
So the second one, yep. So for AND logic, the most efficient is when the condition that takes the least amount of time to check, or that is true most rarely, should come first. For OR logic, the condition that is true most often should come first, as opposed to ANDs, where the one that is true most rarely should come first. And the reason for that is that if you have some statement like this, if hungry or money, right, if sick or tired, stay home. If this is true most of the time, well, the way the programming language works is that it doesn't even bother checking this if this one is true. Why even bother checking the second expression? Because or means that either one of them is enough. So if we're sick, we don't even have to check to see if we're tired in order to stay home. And when I say we don't need to, the computer doesn't. The computer optimizes the code by skipping the second check if the first one is true. And so if you're trying to optimize your code, you want the most common one to be first, because if you can rule it out at the beginning, so much the better. No, that's not worded quite right. Why do two checks if you can get away with just doing one? And if this is the most common one, it would just do the one check before you decided to stay home. But if we put the least common one first, then it has to check that one, and oh, that's false, but maybe the next one's true, and then it has to check the next one. So it's more efficient to put the one that's true most often should come first. So in an AND decision, ask the question that is less likely to be true first. Eliminates as many instances of the second decision as possible, which speeds up processing time. So that's known as the conditional AND operator. Ask two questions in a single comparison. Each Boolean expression must be true for the entire expression to evaluate to true. Does that mean this only works for Boolean variables? No, but it means, like, you know, if x is less than 3 and y is equal to 0. You know, this thing here is a Boolean expression that evaluates the true or false. This thing here is a Boolean expression that evaluates the true or false. Once those evaluations has been done, it can do the whole thing. So the truth tables are the things that describe the truth of an entire expression based on the truth of its parts. We've made up little miniature truth tables here. What do I mean by miniature? Because you can build a truth table for a more complex expression than just x and y, or x or y. And I'll give you a little example, but I'm never going to ask you to do this. What if our expression was x and y or z? Well, then it'd look like this: x, y, z, result. And I'm just going to actually have to think this out. But we have 3 choices rather than 2. So instead of only 4 possible states, we have 8. This should look familiar from our odometer example. Okay, so if we were going to follow the rules of precedence, this is the part that's done first. Now we know, logically speaking, that anything ORed with a true is a true, so we could very quickly answer the ones where z is true. Because if this one's true, the whole thing is true no matter what, just because of that. So that one would be a true. That one would be a true. That one would be a true. And that one would be a true. Now, if this is false, it could still be true under the condition that x and y is true. And now there's only one condition for x and y that results in a true. And do you remember what that is? If we scroll back up to the truth table, for and, x and y is true only in which case?
Only both x and y are true.
Right. So if we come back down here, out of all the ones where z was equal to 0, this is the only one that could possibly evaluate to true. So that's a truth table for a more complex expression. And if you take a logic class later on in your life, then you may wind up trying to optimize these expressions by building truth tables for great big hairy expressions, and trying to figure out if some of the clauses can be eliminated and stuff like that. Now, do I want you to be able to do that? Nah, just tuck it away in your head. The concept that you can make great big truth tables. And you can also have a truth table where the result is always 1, in which case you've written a trivial expression. Even if it's a very complex one, you've written a trivial expression. In a case of a trivial expression, one that's always true, it could be something like this. If x is less than 0, or x is greater than or equal to 0. Right? Is that ever going to be false? No, x is always going to either be less than 0 or greater than or equal to 0. So if we build a truth table for this expression, then the result would be 1 straight down. And you know, well, that was dumb. I should rewrite. I need to figure out what's wrong with my expression there. Skip something. Short-circuiting the evaluation. An expression is evaluated only as far as necessary to determine its truth. Like this. If we have if hungry and money, then if this check is false, this one's not even done. That's called short-circuiting. Short-circuiting sounds bad. Captain, the engines are short-circuiting. No, in this case it just means that it's skipped a little bit of logic in order to speed things up. And it's fine. It's usually a good thing. So, short-circuiting. If both operands, no wait, if the first condition of an AND is false, the second condition is skipped. So if A and B. A is false, then B is not evaluated, just for speed purposes. Or, works a little bit different. If the first condition of an OR is true, the second condition is skipped. So if A or B, if I am sick or tired, A is true, well, if that's true, there's no reason to check the next one. So if A is true, then B is not evaluated. This is known as short-circuiting. And is usually a good thing. For performance reasons. The only time it's not a good thing is if a programmer doesn't understand that, and whatever is happening in here and here, absolutely both of them must run in order for the code to work right. And that would be if these were functions rather than just variables. Like if you had something like this. If check thermostat is equal to true and check engine is equal to true, for whatever purposes. And what if you, when you were writing this, for some reason made the assumption that check thermostat and check engine both must be called together every single time for them to work? Well, in that case, short-circuiting can break it, because there will be times when this one is called without this one. So it would be something that you would need to tuck away into your brain, is that if your AND or your OR statements are hooking up functions rather than variables, then there are side effects to short-circuiting. There could be. Now, you're not supposed to write functions where two of them have to be called in pairs. That's called coupling. You don't usually want to couple your code in that fashion, because if you wanted them both to be called together in pairs, you ought to call them before you get into the if statement. This would be easy to fix. You could do this. A is equal to check thermostat. Then you could do B is equal to check engine. And then you could do if A and B, like that. That guarantees that both of these are true and that neither one are skipped due to short-circuiting. So the only time short-circuiting could be bad is if the code relies on needs both parts to be evaluated. Like if there are function calls that must be called for the program to work. Another case would be something like this. If you do this, if x, and this language doesn't even support it, but you'll see it, like you've heard of the language C++. If you see this, if x++ is greater than 10 and y++ is greater than 20. Now in the languages that supports this, what this is supposed to do is it's supposed to add 1 to x before doing the comparison. And this is supposed to add 1 to x before doing that comparison. But according to short-circuiting, if this is false, then 1 would never get added to y. And if your code was expecting that, that wouldn't work. But line of code is not good if the designer of the functions thought that both functions were going to always be called. So if you had that case, you would just call them before the if statement. Makes the if statement easier to read anyways. You ought to give better names to your variables than A or B though. So in an AND operation, both expressions must be true for the entire expression to be true. If I want to go to the movie and I have enough money, I will go to the movie. Here they're showing that ANDs, are so-called if cascades, like I showed you. They can be made like this. If calls made is greater than that, yeah. If call minutes is greater than that, yeah. And of course they get a premium. Or you combine them with the AND keyword. Is calls made greater than the max number of calls and call minutes greater than the max number of minutes, then the bill gets the premium added onto it. So you can see that by having AND, you make your flowchart smaller, always a good thing, and also your logic is shorter. If I could rewrite this, if hungry and if money, go out and eat, if I can just rewrite it like this, if money and hungry, right, go out to eat. That's how I'd rather do it. Okay, so avoiding common errors in using AND. The second decision must be made entirely within the first decision. Now, honestly, I have no idea what that's saying. Nope, not getting it. In most programming languages, logical AND is a binary operator requiring a complete Boolean expression on both sides. Now that doesn't usually get beginning programmers, but OR is the same way. It's a binary operator that requires a complete Boolean expression on both sides, and that does sometimes nab people. Why? Because people would like to be able to do this. Input Y. If Y equals A or B. Looks great. Not going to work. Here's how you would have to write it. If Y is equal to A or Y is equal to B. That works. So this is bad code. This is good. Why? Because both. If you covered up everything like this still has to be able to be evaluated. The letter B cannot be evaluated. That's not an expression that evaluates a true or false. But if you cover up this part, y is equal to b, that is a valid Boolean expression. You can figure that out. Just like this side has to be a valid Boolean expression. And is the same way. Both sides have to be Boolean expressions or variables that can evaluate to true or false. And the expression should not be trivial. If a is equal to 0 and a equals 0, that would be stupid. Why would you check it twice? So the or decision takes action when one or the other of the two conditions is true. Are you free for dinner Friday or Saturday? Did the chooser use A or capital A? So, depending upon which condition you ask first, does control the efficiency of the comparison. So since if the first condition is true, there's no need to ask the second, you would want to eliminate as many extra decisions as possible. So you'd want to put the most common one true. We'd already talked about that. So the conditional or operator asks two or more questions in a single comparison. Only one of them must be true, one or the other, or both. The questions placed first will be asked first, so consider efficiency. And then the computer can only ask one question at a time. I'm getting tired of this term, ask a question. Tired of that. Oh well. Avoiding common errors in using or. The second question must be a self-contained structure. What does that mean? Like that. That's a self-contained structure. That could be put on its own line of code. That could not be. So both sides of the or statement. That's kind of like in math books, you'll see statements like that, which means that is y greater than 3 and less than 10. That doesn't work in programming terms because everything on both sides of these must be a complete numeric value, right? And if it evaluated this one first and it got a true out of that or a false out of that, then when it was done with that, is true less than 10? What the heck? I don't know what that means. Neither does the computer. So you could not word if 0 is less than x is less than 10. Can't word it like that. You would have to do something like this. If x is greater than 0 and x is less than 10. That's good. So a request for A and B in English logically means a request for A or B. Add $20 to the bill of anyone who makes more than 100 calls and anyone who has used more than 500 minutes. Add $20 to the bill of anyone who has made more than 100 calls or who has used more than 500 minutes. Avoiding common errors in an or selection. The Boolean expressions have to be complete. Make sure the selections are structured. They just have to be valid expressions. Make sure to use or when they are required. Know the difference between your ands and your ors, and make sure that they're not trivial. If x is greater than 0 or x is less than or equal to 0. Alright, time to actually see one of these. Is calls made greater than calls? Yes, then add the premium to the bill. Nope. Is text sent greater than texts? Yeah, if so, add to the bill. So don't do it. This flowchart is not structured. This decision is exited early. Why is that? We kind of have crosstalk between the branches of an if. There can't be any crosstalk until they hook back up together like that, right? This should go over here and do something completely separate than this over here. You couldn't write the program like this. You couldn't sit down in Python and turn this into Python. It's quite possible to draw flowcharts that can't be implemented in logic because they don't follow the rules of structure. And the rules of structure is that each branch of an if are independent until they join back up together at the bottom. So that's invalid. Here's a valid way of doing it. Is our calls made greater than the number of calls? Yeah. Then add the premium to it. No? Okay, then we have to do our second check. Is the number of texts sent greater than the maximum number of texts? Yeah. Add the premium to it. No, don't do anything. So we have a nested if here. Really the fix would be to use an or. Is calls made greater than calls or text sent greater than text? In that case, add the premium to the bill.
Like the one right above it.
Yeah. Yep. That's a good way to do it. That'd be a better way to do it. And there's no way to rewrite this one to make it valid Python unless you just did it like that, in which case it's not the same flowchart. Another error. If the age is less than the minimum age and the age is greater than the max age, then give them the discounted price. Now, how many people are going to get the discounted price?
Nobody.
Nobody's going to get the discounted price because you can't be less than the minimum age and greater than the max age unless those numbers are pretty dang weird. So you would need to fix this. You'd make it or rather than and. And the not operator. The Colbert report, he was always talking about the truthiness. It reverses the truthiness of a Boolean expression. If age is less than 18. If not age less than 18. Output, you can register to vote. And our language likes that. If I'm not less than 18, I can vote.
I mean, but it'd still be easier to just do if age is greater than
Absolutely,
greater than or
absolutely.
equal to.
I avoid using the word not because while the computers are happy with it, the human brain
Yeah, it's
kind
kinda
of hiccups on too many negatives. Like that's why you get told to not write double negatives in your in your English papers or whatever. Yeah, it'd be far better to write that. It is a unary operator, meaning it takes only one operand. You got the what does that mean? If you had and, you had to have both A and B. You had to have two sides of it. But if you have not, that's enough. If that's true and that's true, the result will be true. True and true is true. But here, it only takes one. Not true is false. Or not false is true.
Yeah, that's a little weird.
Yeah. So and or are binary operators requiring two operands. Not is a unary operator, meaning one, requiring one operand. I avoid using not most of the time just for that purpose, just for that reason. It's kind of hard. But if it makes sense to you, feel free. Be careful not to create trivial expressions when using not. If not department equals 1 or not department equals 2, then output employee is not in department 1 or 2. Yeah, okay. I don't even know whether that's correct or not. It's saying it's incorrect. my brain can't process why, but I can accept real easily that this would be a better way to write it. If employee is equal to 1 or employee department is equal to 2, and then you put a not here, so if you're not in department 1 or 2, then print that message out. I'd still try to, I'd rather find another way of doing it. Here's one possible way of doing it. Might look easier, might not. How about if employee department is not equal to 1 and employee department is not equal to 2? That looks better to me. Don't know if it looks better to you. Everybody's brains works in a slightly different way. So making selections within ranges, that's a range check. You compare a variable to a series of values in the limits. You use the lowest or the highest value in the range. Should your endpoints be included? If the endpoint must be included, then you use greater than or less equal to or less than or equal to. If the endpoints are not going to be included, you use just less than or greater than. So items ordered as opposed to discount rate. If you order 10 or fewer items, you don't get a discount. If you order 11 to 24 items, you get a 10%. 25 to 50, you get a 15%. More than 51, you get a 20. And so they built them up a cute little cascade here. Is the items ordered less than 10? Then they don't get any discount. And then, no, that wasn't true. The number wasn't less than 10, so we come over here. Is the items ordered less than or equal to range 2? So they order 24, 11 to 24. If so, they get a discount. If that's not true, then we go and we check the third one. Is it less than 50? If that's true, they get the third discount. And there's always more than one way of wording these kind of things. I'm not sure if my brain likes doing it this way. I probably would have started with the highest discount and started working my way down, right? Mm-hmm. If the number of orders is greater than 50, you get the highest discount. Else, if the number of orders is greater than 30, you get the second highest, right? You know, that's the way my brain works, but this works too. So don't check for values that can never occur. Never ask a question if there's only one possible outcome. Avoid testing the same range limit multiple times. Let's go and look at this dead path example here. Same thing. If the items ordered is less than 10, they don't get a discount. If that wasn't true, but then it turns out that they did order 20, they get the second discount. You get down here, is it less than the third range? Then they get the discount. Else, is it greater than the range? They get the fourth discount. Now maybe it's not clear why that's wrong, but if we looked at it down here, that'd be writing that. Why would you do this? If x is less than 10, do something. Else, if x is greater than or equal to 10, do something. Remember, end-if is just pseudocode purposes, not actual programming code. Okay, so there we go. Is there something dumb about that? Yes, there is. Because if x was not less than 10, then what do we know about x by the time we get here? We already know it's greater than or equal. So that's a redundant check. We could just write this like this and we would just be just as happy. I don't like having the word else in my example, so I'm going to say do thing 1, else do thing 2. So avoid redundant checks. So we're actually going to complete this chapter in one day. But that's just.
Really?
But
Is that what you're saying?
well, we'll see. But
You gotta go to the bank.
yeah.
You know?
The reason why we're getting through this is because we've already been using if statements the entire class before we had a special chapter on it. And I'm sure that I've already talked about and or, have I not? Is that a thumbs up or a thumbs down on and or? Yeah, so the two big topics in the chapter we have already covered. Okay, so understanding precedence. When you combine multiple and or ors into an expression, when multiple conditions must all be true, you have to use multiple ands. If the score has to be greater than min score, and score 2 has to be greater than the minimum score, and score 3 has to be greater than the min score in order to pass. You use ands for all three of them. Apparently you have to pass all three tests before you can pass the class there. You use multiple ors if only one of the conditions has to be true. If the score is greater than the min, or the score 2 is greater than the min, or the score 3 is greater than the min, then pass. Now in this class you only have to pass one of the three. When and or are combined in the same statement, the and operator is evaluated first, just like multiplication. So this is the first thing that would happen. You would scan the whole thing, you'd find that and, you'd put your mental parentheses around there. Then you could have figured that out, or that. Now if this is talking about movies, I have no idea why you would structure any logic that looks like this. If the age is less than 12, or the age is greater than 65 and the rating is G. I wish I had some explanation for why you would be checking that. But anyways, so you use parentheses to force the evaluation to occur in the order desired. So, yeah, that was a dumb expression like I was saying, or like I was just pondering. Here's what they think. If age is less than 12 or the age is greater than 65, cool. And if that's true, then we get to compare it to this second clause. All right, understanding precedence. Mixing and or makes your logic more complicated. You could throw in a whole bunch of ifs and ors in a single if statement, but it could make your code more difficult to read. Always just be concerned about how difficult your code is to read. Program doesn't care if your computer doesn't care if it's difficult to read. It'll run it and do exactly what you tell it to do. But if it's difficult to read, then there's more of a likelihood you put a logic error in it. So, okay, here we go. Apparently, we really want to sell G-rated movies. So we'll give them a discount if it's a G-rated movie, but not for middle-aged people, only for children and seniors. Again, I don't understand why, but here we go. So is the rating, is it a G-rating movie? Yeah, it is. Okay, then we have to do our next comparison. Is the age less than 12? Yeah. Give them a discount. No? Okay, is the age greater than 65? Yes, give them the discount. No. Now to me, this doesn't make it look any easier. They were talking about making, breaking it down into individual steps to make the logic easier to read. I don't think that that's easier to read. I think that you could use some ands and ors there to make it easy. No, I guess I won't say that, because remember when I was looking at that line and I said, what in the world is it doing? At least when it's written like this, I do see what it was doing. Case structures we don't even have, so I'm going to skip that. So the summary. Decisions involving binary Boolean expressions. You use relational operators to compare values and requires both conditions to be true. So in an AND decision, make the first part the one that's less likely to be true. In an OR, either one of them can be true. So in an OR decision, put the first question as the one that is more likely to be true. So to do a range check, you compare it with the highest or the lowest values in each range. And then you can eliminate unnecessary or previously answered questions. So here's a bad way. Maybe we haven't done any programming yet. Why don't we actually crank up idle? We're going to write something and then we're going to take a break. No, notepad, idle. So my name, the date. Grade program. We're going to ask the user for the score, and then we're going to print whether they made an A, B, C, or a D. So I'm going to do it in pseudocode first. I'm going to start my pseudocode off with 3 apostrophes, so I don't have to put comments on every line. This is a way of creating a multi-line comment. Okay. So what I want to do first is have some declarations. I guess I should put the word start there. All my pseudocode should start with the word start. My declarations is I want the minimum grade for an A is 90. So set minimum A is equal to 90. Set minimum underscore B is equal to 80. Set minimum underscore C is equal to 70. Set minimum score for D is equal to 60. And we're going to say that there is no minimum for an F. Everything else is an F. Alright, so what do we need to do? We need to ask the user for the grade. Output into the grade score. We just enter the score. Score is different than a grade. Enter the score, so let's input score. And then let's figure out. Let's tell the user what they made. We're going to need one more declaration though, because we want a variable that can actually hold the grade that they made. But for right now, we're just going to set it equal to empty strings, 2 double quotes. So we want to actually set that grade to A, B, C, D, E, or F, or something like that, so that we can print it out. So we're going to write some if statements. If grade is greater than or equal to minimum A, score. If score greater than or equal to minimum A, grade is equal to A. And so on. So let's do that. If score greater than or equal to the minimum grade for an A, min underscore A, then grade, set grade equal A. Okay, now I'm going to do some typing that I don't really want you to follow along with, because I'm going to wind up correcting it. This is valid but dumb. Like I said, don't do this because I'm going to. Okay, why did I say it's dumb? It's starting to wander across the screen like that. Python has an elif, which stands for else if, meaning that we could put these things on the same line, like that. And that would be a lot better, because then, you know, our tab levels are not wandering across the screen. So, that's how we would actually write it. So, else if, although if it was in Python it'd be elif. I don't mind actually using elif. Score greater than or equal to minimum underscore b, set grade equals quote b. Elif score is greater than or equal to min underscore c, set grade equal to c. Just keep going, do it for d. Elif score greater than or equal to min underscore d, set grade equals d. And then if none of those cases is true, they made an F. The other thing we could do is we could just set grade equal to F to begin with and then not even have a final else. But it's always a good idea to have a final else if you have a whole bunch of if-else ifs. Even if it's just to print an error message that says unexpected condition. Because if we don't have a final dangling else, and if none of these things happen, then nothing happens. And maybe that's what you want. But quite often, that's not what you want. Okay, here's something else that I don't want you to type. Right, what we just did was effectively this. If score is greater than or equal to 90, you made an A. Else, if score is greater than or equal to 80, you made a B. Like I said, don't type this. I'm just going to wind up deleting it. You could write it like this. If score is greater than or equal to 90, you made an A. And then you could write if score is less than 90 and score is greater than or equal to 80, you made a B. And then you could do if score is less than 80 and score is greater than or equal to 70. You see where I'm going with this? This works the same way. But why would you write the more complicated one? Which one took me more typing time? Doing it that way or that way? The second one. Longer to write, more prone to errors. More things that I would have to change if I wanted to change the breakpoint between 80 from, you know, B from an 80 to something else. Now we kind of obviated that problem by using these variables, these constants, in order to hold our temporary grades. But that does point out the other problem that you can have when, not that that's a problem, that's just a bad way of writing code. What if we did this? If score greater than 90, then grade equals A. If score is greater than or equal to 80, grade is equal to B. If score is greater than 70, grade equals C. Is that good code or bad code? Let me ask you what your grade would be if your grade was a 90.
It'd be an A.
It would be, and then it would be a B, and then it would be a C. Why is that? 90, yeah. Let's say I made 100. Is 100 greater than 90? I sure is. I made an A. Then it comes in the next line. Is 100 greater than 80? Yeah, it is. Is my grade greater than 70? Oh, yeah. Kind of, you know, okay, my grade's plummeting while I watch. So that's why we would want to use elifs. We would want to have our else statements in there. Now, flowcharting doesn't really have an elif. I guess you could just stick the word elif inside the little diamond, just like we've been sticking if. Okay, so that's why we need else's rather than just mirror ifs, because we want these to be mutually exclusive conditions. You don't want it to allow it to flip your grade to an A, to a B, and to a C, and to a D. Alrighty. So, and then we're going to output our score. Output grade. And we're going to be done. Now, after all that stuff I said not to type, I'm back to actually typing stuff now. So here's our program. We had our start. We had our declarations. We asked for the score. We input the score. We do all that to determine, to convert that numeric score to a grade. And then we output our grade. Now let's actually write that as Python. I'm going to kind of knock that over to the side and make a new file. You don't need to. You can put it all in one. I just want to have them side by side. And so I'm going to do a save as, put this into Python, into my scripting directory. Call it June 28. I keep thinking it's the 28. June27.py. I guess I'll just save this one as June 27 pseudocode. But like I said, you don't have to break them up. If you're putting them all in the same line, in the same program, just end your comment, end your pseudocode with the 3 quotes. So that stuff that you start typing is no longer green. Because we started it with 3 quotes. Go ahead and end it with 3 quotes. Alright, I actually want to turn this into this. Again, I better put my comments over the top. So there's no start command in Python. If you're really missing typing it, you can put it in a comment. There's no declarations command in Python, but we could put it in as a comment. There's no set, so we're just going to do min underscore A equals 90. Min underscore B is equal to 80. Min underscore C is equal to 70. Min underscore D is 60. Min underscore E. Wait, there is no E. Everything else is an F. I'm going to put that as a comment. And then grade equals quotes. So why did I put min A, min B, min C, and min D in all caps, but I didn't put grade in all caps?
Those are your variables.
Right. The ones that are in caps, we have decided are what? Constants. Yeah. Constant variables. But yeah, these are constants that are not going to change halfway through the program, whereas grade certainly is going to. All right, so output. We're going to replace that with a print statement. Print into the numeric score.
Hey,
Yeah.
real quick, can you go back to the other Python so I can finish typing this one? I kind of got caught up behind.
Right there?
Yeah.
All right.
And
So whenever we input a number, it's a 2-step process. We call the input function and then we call float. But you don't just call float as a matter of course for every input you get. If you ask somebody for their name, you're not going to use a float function on it. It's like if you have a microwave and you have a fridge. Everything that comes out of the fridge is cold. Does that mean that you're going to stick everything that you pull out of the fridge in the microwave? No, only if you want it warm, right? You don't normally nuke your milk before you drink it. So let's get our input. Score equals input, parentheses in parentheses, Oh, and really I should have defined a score declaration up here as well. Remember that in Python you don't have to declare your variables before you use them, so I didn't have to put score up into declarations, but to be strict by the book I should have. I think I'll go ahead and do that. I'm going to come up here and I'm going to do score is equal to 0. Just to be by the book. Alrighty, so I have a score, but I need to convert it to a float. Score equals float parentheses score. And by the way, you can mix those up into one statement if you wanted to. I'm going to type it and then I'm going to erase it. Or maybe I'll just put it as a comment. I could have done this. Score equals float parentheses input parentheses in parentheses in parentheses. If you like doing it that way in the future, sure, no problem.
Can't you just replace the print statement next to enter the numeric score, replace that with input, and it'll just...
Yeah, I could do that as well. Well, if you put input there, you better do this.
Yeah, there we go.
Right. You can do that. You can do that. That's a perfectly valid way of doing it.
Now, for float, if you have like several different ones you want to float, and that one you put the score equals float, where you have the float and then the open thing, you can put what all the different ones inside there with a comma separating each one?
No, you have to convert each one individually.
Oh, okay.
Yeah, good question. But float will only accept one parameter. The parameter could be a call to the input function. So that is a good point, and I haven't been doing it in this class, and I'm not sure why. But I'm just going to type stuff that I don't want you to do. You could do this. Name is equal to input, quote, parentheses, quote, what is your name? You don't have to do a print followed by an input. You can put the body of your print right there inside the input. And I know the reason now why I haven't been doing that is because that's a Python specific thing that's not supported in other languages. But if you want to do it that way, that's cool. And then in the same way, you don't have to put your float and your input statements on 2 lines. You could do this. This is totally not part of our program. You could do age is equal to float, parentheses, input, parentheses, what is your age? Like that. Now we're just mixing up multiple things on the same line, but that's okay. That's totally plausible Python. I'm going to cut this and paste this over into my notes because I don't want that actually in my program. Alrighty, now we have our score. We need our if statements. If score is greater than or equal to min underscore a, colon, grade equals quote a. And since I'm okay, if score is greater than or equal to min underscore b, colon, grade equals b. Alrighty. Now I'm lazy, so I'm just going to copy those 2 lines and paste them to do my C and my D. Copy, paste, make some changes. Min underscore C, grade is equal to C. Min underscore D, grade is equal to D. And then my final thing is an else to handle all other cases. The grade is equal to F. And what's left to do? Output the grade. Print that grade, or that is grade equals end quote comma grade. I typed this in uppercase just because, you know, English, we like to see uppercase letters, but the variable was declared as a lowercase variable, so make sure that that one is not capitalized. I guess I could clarify that by saying B grade equals whatever. And then # stop if I feel like having everything that's in my pseudocode. I forgot to put an indiff in my pseudocode. I guess I'll forgive myself. I'm going to run it and test it. Enter the numeric score, 75. See. Now, in testing purposes, you need to test every route that your program is expected to be able to do. In this case, I would want to test every single possible path. I'd want to see it print A, B, C, D, and F. And furthermore, when you're testing, you want to handle those edge cases. What's that? If I say that I typed in an 80 and it tells me that I made a C rather than a B, it's probably because I did greater than rather than greater than or equal to. So these boundaries like 90, 80, and 70 and stuff like that, I should be testing those.
So it just stops as soon as you enter a score, it gives you the grade, and it stops. So anyway, we can loop it so it keeps asking.
That would be the better thing to do, would be to loop it to keep asking. And how would we do that? We might put the whole thing in a loop, and then if the score was equal to -1, then stop. Something like that. I want to get this working and then we can do that.
Gotcha.
Okay, so common little bugs, having the word set in there. Remember, set is pretty much a pseudocode only thing. We don't put the word set in there. The one that more people did is they made their code look kind of like this. And then when you ran it, you got an error. It says unindent does not match any other outer indentation level. And it's because the elif has to be indented the exact same way as the if that's above it. So, take all those out. Alright, so what do I want to do now? I don't want to just enter one score. I want it to let me enter a whole bunch of scores. Now there's two ways I could do it. One is I could ask something like enter score or Q to quit, something like that. Or I could say enter score, they type it in, I display the score, and I say do you wish to run again? And they do a Y or an N. I think I'm going to do it that way. I think the other way is actually cooler, but I'm going to do it this way. So what am I going to do? I'm going to declare a variable called repeat, or again. Something that will allow us to use this stuff over and over and over. And what I really should do is I should print this in its own, put this in its own function, in its own module. But barring that, how about we do this? Choice is equal to Y. And then while choice is equal to Y, or choice equals lowercase y, colon. Now take everything that we've done, except Josiah added a line at the bottom that said, you know, input done or whatever. You wouldn't do that, but every other line of code needs to be indented, right? So we have our while, and everything under that should be indented. And now let's ask them if they wish to repeat. So at the bottom, choice is equal to input run again, question mark, y/n. End quote, end parentheses. There's the while right there. That's the stuff that we added here. And then at the bottom, we want to ask them for that choice. Choice is equal to input, parentheses, quote, run again. This is just demonstrating, right, that the input and the print statement can be combined into one thing. So I'm going to put a comment here, end if, and then if I wanted to, I could put my final little input statement. That press enter to complete or something like that, but that's enough. So now when we run it, enter the numeric score, 90. Run again, Y. 80, Y.
For some reason now when I do it, it says enter numeric score, enter the score, and I don't get anything. I don't get it. It just keeps asking the same question over and over.
Oh, let me come look.
That's what.
And this should really be end while. And we just added that. To make a loop is we had a huge chunk of stuff look like this. Don't do what I'm about to do. Is we had all that and we said, okay, but I'd really like that to loop. By the way, to get rid of my indentation, I'm just going up to format dedent. And we said, okay, what I'm going to do is I'm going to do a while, and whatever my condition is, and then all of this has to be tabbed and put inside it. While choice is equal to Y, whatever. If this wasn't tabbed over, then what it did is that's the end of the loop. The first line that is tabbed equal to the tab level of the while statement. It has this imaginary end while above it. And is that what we want? Do we want it to print enter the score and then it calculates the grade and then it doesn't do anything and it asks for the score again? And so if that was the case, what you saw is it kept asking enter the numeric score, enter the numeric score, enter the numeric score, and it never asked you. Excuse me, it never gave you the answer. So that's why that needed to be tabbed. Additionally, if we never got any new input, it would never leave the loop. And so that's why we had one more while down here at the or another input. Choice is equal to input, continue Y/n. Both of those also that one had to be tabbed too. Because if that was tabbed, then it would never get to it. Because this is the end of the while loop. Well, that is now, because this is the first unindented line. The first unindented line serves as the end of the while loop. It never gets to that point. It keeps looping before it ever gets to ask. So that one had to be tabbed over too. And then by doing that, that made that the end of the while loop. Now what we could have done is this. I'm going to delete all that. Well, I could have taken that code that we wrote and made it its own module. So here was our code before we started making a loop. I could have done this. Define do grade, whatever. And then at the bottom, return. So this is the code that handled getting the score, converting it to a letter, and displaying it. And then down here I would have some main code to start. And it would look like this. Choice is equal to Y. While choice is equal to Y. Do grade stuff. And then choice is equal to input. Run again, question mark y/n. End while. We could have gotten it to work either way. I chose just to make it do it without a module, but sticking it with a module in there, kind of, I don't know. Don't know if it would conceptually make it easier or not. Alrighty, so the last thing I want us to do is one more little bit of flow charting, one more little bit of coding, and then we're going to do a review. And I would just take what we did here and make it a flow chart. I guess we could do that. Why don't we do that? We're going to turn the code that we just did into a flow chart, and then we will call it a day after our review. So I'm going to go to Lucid Chart. Line and log in with Google. Make a blank document. This one's going to be pretty easy because it doesn't have any module calls or anything like that. So we need our start terminator for our main code. There's no module, so I'm not going to have a DEF circle. I'm just going to have a start. Then we add some declarations. You can put all your declarations in one box. Declarations, and remember you can hit Control Enter to add extra lines. Min underscore A equals 90. Min underscore B equals 80. Min underscore C equals 70. Min underscore D is 60. Looks like I have 79 there. And then I had a grade variable and I had a score variable. Then what was the first non-declaration line of our code? We had a choice variable. I guess that we could have thrown that up into declarations. Choice is equal to capital Y. So then we have a while loop. I'm going to simplify the while loop and just make it while choice equals uppercase Y, just because putting that OR clause in it makes it too big to fit in the diamond. So underneath that, put our decision block, while choice equals quote Y. We're going to input our score. Inputs are done in tilted. So input score. And now we have our whole bunch of ifs. 5 of them to be precise.
There it is.
So ifs also go in diamonds. If score greater than or equal to min underscore A.
It was while choice equal Y, right?
Yes, yes, yes.
Okay, want to make sure.
All right, and here's why I shouldn't have used elifs, because they're hard to flowchart. Oh well, we'll just go with it. Okay, so if the minimum score is greater than or equal to Y, then what happens? We do a little bit of math to set our grade variable. Set grade equal to quote A. No? Well, just fall through to another one. L if score is greater than or equal to min underscore B. And we need to make this one loop back like that. We could make them join together to circle. I'm not going to take the time to make it go to a circle, but you can't have a dead end. And so if that's true, set the grade equal to B. And so on. Do the C. And if the score is greater than C, then set grade equal to quote C. So here's my story till now. Have my declarations up here, my while. I need to handle the D, and then I'm going to have one more for an F. So L if score is greater than or equal to min underscore D. Set grade equals to D. And lastly, if that wasn't true, we have one final else. And if that was the case, we set grade equal to F. And they need to rejoin back together after that. Did I have to make this set go off to the side like that? No, it could have been under it, under the block. That could have gone conceivably right there, and it would be just as valid. All right. So what was the next thing in our code after all of our if-elses?
The output.
Yeah, with the output, and then we ask whether they want to continue or not. So let's output the score, output the grade. And then let's input that repeat variable. Now that's the bottom of our loop. Since it's the bottom of the loop, we need to draw a line going back up to the while statement. The books would have you do it like this. They would take a line, they would drag it, and they would go all the way up to there, like that, somehow. That's a totally cool way of doing it. I personally kind of prefer drawing the line on the inside. Sometimes it makes it easier to draw that line going up. Either way, as long as you have a line from that input repeat going back up to your while block, you're good. I am going to make it go to the outside. Do it book perfect. Just have to move that line out a little bit.
Can you go back to the part where the F statement is?
Right there.
I know I messed up somehow.
And then lastly, all it did was print some kind of done message. So from the after this on the no block, you just printed okay, done. Hit enter to quit. Something like that. Okay, output done. And everything has to end in a stop or a return. I like putting my stop or return actually below at the rest of the code, although it stretches out the flowchart a lot. Here's what it looks like when I'm zoomed away. Declarations, here's my loop, and here's my output done message.
How does one zoom out again?
Hold the control key while spinning the mouse wheel,
Okay.
up or down.
Gotcha.
Now I'll briefly mention why. Well, this flowchart isn't 100% accurate. The book wouldn't show it to you this way. The problem with it really is that else ifs are mutually exclusive. Meaning that if it was an A and it went over here, then it could never trigger the B or the C or the D. And so technically these lines should not be coming back here. But I didn't want to suddenly violate our drawing of ifs by doing anything else. So I let it stay like this. But if we saw the book do it, they would have done if, else if, else if, else if, else if, you know, as a cascade.
For the final no statement, what would the boxes connected to? Okay, thank you.
Alrighty, gang. So, reviewing for the exam. Know the difference between Python, pseudocode, and a flowchart. In other words, if I have a picture of a flowchart and I ask you which it is, pick flowchart. If I ask you whether it's pseudocode or not, you can tell it's pseudocode because it's not going to have the word set. That's probably the easiest thing to zoom in on. But if you compare, our two pieces of code here, our pseudocode and our regular code, we're used to the differences. Pseudocode is loosey-goosey, doesn't have colons and everything. Has the word start, has the word stop, doesn't hardly have any comments, it has the word output and things like that. Then you know it's pseudocode. So 3 kinds of errors. What would you call an error that, a mistake in the grammar or typo? That one is a syntax error. A logical error is a mistake in the logic of the program. It runs but does not behave the way it happens. It's supposed to work. Yeah, so if the program runs but does not behave correctly, that's a logical error. Know the difference between something like this. Which one is a string?
The one with the apostrophe.
Yep, that's a string. You can't do math with it. You'd have to convert it. Which one's a integer?
Integer would be the whole number.
That's a whole number, and a floating point is a number with a decimal point. So what is the smallest unit of information a computer can hold? If I give you a bit, or a byte, or a liter, or whatever, a bit is the smallest, right? The bit's the smallest. It can equal either 0 or 1. What is a byte? ASCII is 7 bits padded out to 8. A byte is 8. Yep. So in terms of precedence, remember PEMDAS, meaning parentheses first, exponents second, multiplication, division, and addition and subtraction. And by the way, what is the exponent symbol? It's not that.
It's 2 stars.
It's 2 stars, right? What is a modulus symbol? It's the percent sign. So like, what is 5 modulus 3? Well, 5 divided by 3 is 1 with a remainder of 2. So 5 modulus 3 is 2. So we had our data types up here, ints versus floats versus strings. There's one more, bool. The bool is the one that can hold true or false. Except Python capitalizes them, true or false. While we're talking about operators, what's the difference between division and floor division?
Floor division is where you're rounding it to...
Exactly. It discards the remainder. So 5 floor division 3 is just 1, rather than being 1.666 or whatever. Excuse me, that should have been, I said floor division. 5 floor division, 3 is 1.
And then 1 slash includes the remainder.
Yep.
So it's 2.
So 1 divided by 3 is, or 4 divided by 3 equals 4.333, right? But 4 floor division 3 is just 4. Please understand that if you're talking about conversion of binary numbers, which we've done a couple of times, if you have something like this and you're trying to convert it, the places are, that's the 1's place, that's the 2's place, that's the 4's place, and that's the 8's place, and so on. 1, 2, 4, 8. And if you wanted to turn those into powers of 2, that would be 2 to the power of 0 on the far right, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that. And if you needed to keep going, you wanted something more than 4, like ASCII is 8 bits, we might want to go out all the way to 8. We could tack on a 16, a 32, a 64, and a 128, which would be 2 to the power of 7. Just because I'm typing to the power of like that, that's not the way Python does it. It does star star. 2 to the power of 6. 2 to the power of 5, 2 to the power of 4. Something like that. We have done some conversions. I will give you a binary, a conversion chart if I want you to go from hexadecimal to binary. You remember doing that in one of our homeworks.
I do. I remember that.
So for example, show why the binary number 1111 is equal to 15. Why would that be? Because it's equal to 8 plus 4 plus 2 plus 1. What is a sentinel value? Know what a sentinel value is. I think we even hit it back in the beginning of chapter 1. What was it?
The sentinel value is something that prevents an endless loop.
Right. It's the terminating value of a loop. We could even say it's an invalid element of data used to terminate a loop. Something like that. Value that ends a loop. Your other best bet should be to review your tests, your MindTap tests. Because I'm not giving you every question that's in here, especially if it's one that I know is taken from a MindTap test. If I asked you for 3 attributes of a variable, name 3 attributes of a variable. Something like that. Don't go float, int, and string. Those are types of variables, not attributes. Attributes have several parts. Variables have several parts. They have a name, they've got a type, and they've got a value. if you're taking the bird's eye view and you're looking at just dividing your code up into modules, stuff like that, is that called extraction, extinction, or abstraction? It's abstraction, right? We're ignoring the details, we're getting the big picture, we're moving the code into modules so that we can do abstraction. So for a module to work, does it have to have a header? Yeah, it's got to have a header. It's got to have that DEF line. Does it have to have a body?
Yes.
Yeah, it's got to have a body. Does it have to have local variables? No, it doesn't have to. It might, but it doesn't have to have them. Does it have to have a return statement? Well, according to the book. But I'm not going to ask that because in Python it doesn't. All right, I may ask you to draw a flowchart. I may ask you to do some pseudocode. I probably won't ask you to do both. Honestly, what I'm likely, 90% likely, that I'll give you pseudocode and ask you to flowchart it.
Right.
Alrighty, please review your MindTap exams.
Yes, sir.
And then we are good to go. Let's make a Dropbox so that we can call ourselves done.